All right, next round of identities. First one is your product to sum. So this is used when you take two trig functions in either sines or cosines that are being multiplied together, and you change it to a sum. Now remember, a sum could be viewed as addition with subtraction could be viewed as a sum with a negative in there. So that's why we just say product to sum, because it's like plus a negative. All right, example 1, express each as a sum or difference. So I'm going to use the angles to identify. So our first one is the sine and sine. So here, alpha, just so we can relate that formula at the top, is 8x, and beta, that's the B, looks like a B with a tail, is our 4x. So we're using our product to sum of sine times sine. So that is going to be 1/2 times the quantity cosine of alpha, which is 8x, minus beta, which is 4x, minus cosine of alpha, 8x, plus beta, 4x. So our 1/2 is just kind of floating here. 8 minus 4 is 4. And then 8 plus 4 is 12. So it's a sum. Difference. Or. Sometimes words are hard. That should say or. All right, B. Cosine of 5x over 2 times sine of sine of x over 2. So this time we're using the cosine times sine identity. So that's going to be the fourth one at the bottom. So alpha is going to be 5x over 2. And beta is x over 2. So again, we're using that bottom left one up here. I just can't leave it up there while I'm writing. So that is 1/2 times the quantity sine alpha, 5x over 2, plus beta, x over 2, minus sine alpha minus beta. So 5x over 2 minus beta, which is x over 2. So that gives us 1/2 times the quantity sine of 5 plus 1, 10. 10 over 2 is 5x, minus sine 5 minus 1, 4 over 2, 2x. Right? Sum to product identity. So this is your next round of identities. So this time it's going, instead of from a product to a sum, it's going from a sum. Again, a difference is just adding a negative to a product. All right, so in this case, since I wrote these in terms of x and y, again, you got to get comfortable seeing the different letters. So rather than identifying alpha and beta, I'm going to identify them as x and y. All right, so in this case, we're doing sine of 8x plus sine of 2x. So that's using this top one up here, sine plus sine. So x, again, not speaking with that x, this x, as far as the formula at the top is concerned, is 8x, and our y is 2x. So sine of this plus this is 2 times the sine of the sum of the angles divided by 2, kind of like the average. So x plus y all over 2. Come on, division bar. Times cosine of the difference in the angles divided by 2. So 8x minus 2x all over 2. So that is 2 times sine of 8 and 2 is 10. 10 over 2 is 5, so 5x. Cosine of 8 minus 2 is 6. 6 over 2, 3x. For B, cosine minus cosine, so we're using the bottom one this time, since it's subtraction. So x, 9x, and our y referencing the formula 7x. So cosine minus cosine, negative 2, sine the sum over 2, so that would be 9x plus 7x all over 2, times sine of the difference over 2, so 9x minus 7x all over 2. All right, so we got our negative 2, sine 9 plus 7, 16 over 2, 8x, times sine 9 minus 7, 2x over 2, x. Put these two really far apart. Oops, there you go, you can kind of see both. Next, verify the identity. So just like with all the others, you can be using these to verify identities. All right, so if I'm looking at this one, that right side is awfully simplified. I do not want to mess with it, so I'm going to go to the left side. I see sums and differences, so I'm going to go change those to products. So cosine for the top is cosine minus cosine, so we're going to use our sum to product identity from the top. So here, I'll write it up here. So our cosine minus cosine identity is negative 2 sine of the sum over 2 times sine of the difference over 2. So we're going to use that one for our numerator. And then our denominator is sine plus sine. So we're going to use our sine x plus sine y here. Sine plus sine is 2 sine. Sum over 2 times cosine difference over 2. So we're going to use those. All right, so cosine of 3x, so we're going with that top one here. Again, let me get my large division bar drawn out. All right, so negative 2. I don't like it right there. Negative 2 sine of 3x plus 5x over 2 times sine 3x minus 5x over 2. For the denominator, sine plus sine, 2 sine sum 3x plus 5x over 2 times cosine of the difference 3x minus 5x over 2. All right, so if we look at these, compare my numerators and denominators, the 2's drop, 2 divided by itself is 1, so those are gone. And then I look at the 2 sine functions, those are actually identical as well. So these 2 are going to divide out since everything's being multiplied. So that leaves me with the 2 sines and then the negative. So I'm going to simplify, or the sine and the cosine and the negative. So that is a negative sine of 3 minus 5 is negative 2. I don't need it. Negative 2 divided by 2 is negative x. So sine of negative x over cosine 3 minus 5, negative 2. Negative 2 divided by 2, negative x. And then sine over cosine of the same angle, reciprocal identity, as long as the angle matches, you can change it, is tangent of negative x. You got to hold the angle constant. And then using our even odd identities, tangent is odd. So negative inside is as if we brought the negative over to the outside. But because there's already a negative there, that makes it a double negative, so they drop. And we are left with tangent of x. Example 4, another verification. I think that's it. Yeah, this will be pretty quick. All right, because the right side is already condensed to a single trig function, I'm going to go to the left. So we're going to use the difference in sines and then the difference in cosine. So we used the difference in cosines last time, but we did not use the difference in sines. So here, I'll write that one down. So sine of x minus sine of y, again from that list at the top of this page, to sine difference first this time, times cosine sum. So we're going to use that one for the numerator. And then the same one we use cosine x minus y. I'm lazy. I'm going to go get it. Copy. Okay, so there's our two that we're going to be plugging in. All right, so division bar. All right, sine x minus y. 2 sine of the difference, so 2 sine of the difference over 2 times cosine of the sum. And then for our denominator, cosine x minus cosine y, negative 2 sine of the sum times cosine, times sine, the sines and cosines all over the place, x minus y over 2. All right, so if we look at this, 2's are going to drop, so the negative doesn't, but the 2's do, and then I've got an x sine of x minus y over 2. I also have a sine of x minus y over 2 in the bottom. They're just not directly under each other, but they still divide out because the order you multiply in does not matter. So I am left with, I've got that cosine x plus y over 2, and then sine, or negative sine technically, x plus y over 2. So our angles are the same. So as long as I hold the angle constant, cosine over sine using the reciprocal identity is cotangent x plus y over 2. And voila. Right? Careful with those identities. Don't get those sines and cosines mixed up.